Okay, so let's have a look now at the simplest polygon, which is a triangle. And our triangle has three sides, okay, 1, 2, 3, and it has three angles at these three vertices here. Okay, what you'll see on these shapes is that they will indicate the length of the lines by these particular markings. And if lines are the same length, they'll have the same marking. So if these two lines, for example, were the same length, then they'd both be marked with the double stroke. The angles will be marked with an arcing type shape like this. And if they're the same angle, they'll be the same size. In this case, the three angles are all different. So this one gets a double arc, and this one again gets a triple arc, like that. So what we can see with this particular triangle is that it has three different side lengths and three different size angles. So as such, it is what we would call a scalene triangle. And that is, it has three different side lengths and three different size angles. Triangle here has two side lengths here that are the same, and then they're marked by these two lines, telling us that those two are the same length. Okay, and obviously this third side is a different length. And we're given these two arcs here that tell us that these two angles are equal. So this is an isosceles triangle. So two equal sides, two equal lengths. We can use this information to work out the other angle size, because one of the other things we know with a triangle is that the total angle size inside a triangle is 180 degrees. In this triangle here, we can see that the lengths all are marked with the same markings. That tells us that the side lengths are all equal, and the corners are all marked with the same symbol, so the angle length are all the same. So this tells us that there's three equal sides and three equal angles. It must be an equilateral triangle. Now, because we know that all triangles have a total internal angle size of 180, if all angle sizes are the same on this one, it'll be 180 divided by 3 equals 60 degrees. So in an equilateral triangle, the three equal angles must always equal 60 degrees. Okay, looking here, we can see here we have a triangle that has three angles on it that are all less than 90 degrees. And this makes it an acute angled triangle. So looking here on this triangle here, we can see we have the symbol in the corner for 90 degrees and for a right angle. So this triangle is called a right angle triangle. And so whenever we see that symbol, we know that that angle in here is going to be equal to 90 degrees. And then that allows us then to use that knowledge to help us if we were trying to calculate some of the other angles in that triangle. Okay, so we can see in this angle we have a different sort of fanning out of the sides here. We have this angle here which is greater than 90 degrees, but it is less than 180 degrees. So this angle can be described as an obtuse angled triangle. As already mentioned, if we're looking at the angles that are inside a triangle, if we add them together, so A plus angle B plus angle C, so A plus B plus C, it's going to give us a total of 180. And just to explain how that sort of comes about, if we look at something like a square or a rectangle, like this, if we split that from corner to corner, okay, we end up with two triangles. And what we know with these rectangles or squares, that each of them have a right angle in the middle, in the corners. So 4 lots of 90 is 360, and half of 360 is going to be 180. So 180 in that triangle and 180 in that triangle, giving us a total of 360 for the entire rectangle or square. So we can apply that knowledge to every one of our triangles when we're trying to calculate what the angles are. This scenario, and we're given 70 degrees here and we're given 30 degrees here, and we're trying to find x. What we know here is that 70 plus 30, so we're going to have x is going to be equal to 180, which is the total. Take away 70 plus 30. Okay, so we add those two together, that gives us 100. So 180 take away 100, it's going to leave us with the x angle, in this case, is going to be equal to 80 degrees. Okay, so those internal angles must always add to 180. Okay. Okay, and we're told perhaps that this one here is 25 degrees. Then what we know is this one's going to be 90. So we can know then that it's going to be 180. Let's give this one the y. It's going to be y is equal to 180 take away 90 plus 25. Okay, so 180 take away 115. So our y value here is going to be equal to 65 degrees. Okay, so here we have an isosceles triangle because we have the two sides here the same length, which means these two angles are the same, okay? So in other words, we know that this is C, angle C is going to be the same as the angle here, okay? So what we know here is that 2C is equal to 180 take away 30. So 2C is equal to 150. So therefore C must be equal to 150 divided by 2. So it's going to be equal to 75 degrees. Okay, so it's going to be 75 in here and 75 in there. Let's have a look at the idea of exterior angles and interior angles. So here's our triangle, and if we extend the line along the bottom here to create a line on the outside, it creates for us an exterior angle out here. And what we know is that the angle of the line is 180. And so we can think in the same way that if this angle in here plus this angle on the outside equal 180, then in actual fact, the angle in here plus the angle on the outside is equal to the two opposite interior angles. So to make it easier to understand, effectively C is equal to the opposite angles A and B added together. So if we think of this as an example, let's consider that if A is equal to say 50 degrees and the B here is equal to 60 degrees, then 50 plus 60 will equal the C on the outside here, which will be 110 degrees.